Yeah, his research interests cover DevOps, software development, and the separation concern mechanisms, focusing on domain-specific languages, model-driven engineering, and software composition. And Dr. Anne-Marie Pinna-Déry is a professor of computer science at University Côte d'Azur. Her research interests cover human computer interactions, software architecture, and distributed systems. In 2003, she started teaching courses dedicated to HCI and human-centered design, first with visually impaired children, and more recently with the aging population. So without further ado, I'll pass the podium to the virtual podium to Sebastien and Anne-Marie.
Well, thank you very much, Rong, for the introduction. So, yep, what I'll try to do today is to go through building software for the aging population, because that's more or less the idea and the objective of your the program you're in, and also to give you like a point of view from the software engineering research community, what we are doing in this context, how can it help, and the kind of tools, method, and techniques that can exist in this context to support this kind of things. So who am I? Well, basically, I'm a software engineering researcher. So I've got an engineering degree from France, and I moved to north of France, Norway, and then finally I've ended in Canada. But basically, I've worked in the context of developing applications for a population that are not kind of usual when you're doing your studies. Initially, it was with visually impaired children, because as I said before the beginning of the talk, I was a student of Anne-Marie when I was younger. So, and I was attending the course she was giving about developing serious games for visually impaired children. And then by evolving and moving to Norway, I was more working on living labs and Internet of Things and the kind of technology you can develop to support elders to stay at home. And then when I came back to Nice and then moved to Montreal, it was more about the aging population in terms of designing systems supporting those kind of users. So I will be the one talking today, but it's really like a job and things we're doing together with Anne-Marie, and actually it's more than the two of us. The things I'm going to present today are done in the context of Samuel de Champlain program, which is a French-speaking alliance collaboration between France and Quebec. And it included people from Université Côte d'Azur in Nice, France, so south of France, UQAM in Montreal, and also people from Toulouse in also south of France, but a little bit to the west. And that's a project that started in 2019, was kind of slapped by the pandemic, but we're still trying to work together, and it included like close to 12 people who worked on the kind of things I'm going to discuss today. So first, the question you can ask is, okay, we are developing software. We are both, Anne-Marie and me, software engineering teachers and professors. So why should you focus on aging population? Why should you? Because it's not the easiest way to develop software. So why is it important? Well, basically, we do consider that it's part of your responsibility as an engineer to be inclusive, like as inclusive as possible. It's kind of reasonable. And if you just decide to create an app that would exclude soccer player because you hate soccer, it would only exclude 3% of the population, which is quite a lot because it represents 250 million people, but still way less than if you decide to exclude elders from the use of your application. The projection for Japan, which is kind of the most extreme case, is that 75% of the population will be 65 plus by the next 20 years in Japan. So it's not just about excluding 3% of the population. It's really like, if you don't take into account the difficulty and the problems that can arise when you're aging in the way you're designing the software, then you're not all inclusive, which is like a really huge problem, because as I said, aging is difficult, but it also triggers special requirements, special needs that you need to take care of. And something which is also different is that it's often linked to medical conditions. So that's something where software developers and software engineers are not really used to, because, well, we're not physicians, we are software engineers. So we need to find ways to include this in the ways the software are developed to make sure that it will be possible to use the software. We can take an example, like there's a pandemic, everybody knows about this right now, and there's a vaccinal pass that is implemented in Quebec and another country. I think it's the same in Ontario. So if you want to go to a non-essential service, like going to a restaurant, you need to show your vaccinal passport, which is in Quebec implemented as a mobile app. They took people into account when developing this. So it has a simplified user interface and user experience. It's basically you click, scan, and go. So that's really easy to use, and it's really easy to add a proof. It has some drawbacks, like it requires a smartphone. It can be fragile with automated updates, and it's so easy that it's possible to create a fake proof of vaccination, which can be a problem. But if you just look at this, it looks like they've taken into account people while designing the software, and that the user interface was inclusive in a way, because it's really difficult to be more simpler than what it is. Well, actually, that was a huge problem in Shawinigan, which is a really small town in not that remote, but really small. An association named Trade Union was helping up to 400 people a day to obtain the vaccinal pass. And you can say, okay, it's just to access restaurants, so it's not such a big deal. You can live without going to a restaurant. I mean, we did it during the lockdown. But if you consider that starting 2 years ago in France, it's not possible to file your taxes declaration, tax return, without using the internet and without using the web app, then you can start identifying that there are some troubles here, because it can be really complicated / scaring to go to the internet and use a computer to fill your taxes. And that's the very same to access your pension schemes, could be the same to access your medical records. We are more and more pushing the society to use digital services and digital application. And if we don't take into account elders in the way we're developing this, then it will be a huge problem. So it's not only an engineer's responsibility, it's also a professor responsibility. We need to improve our research, and we need to improve our teaching to prepare the next generation of students into being inclusive by design, and starting at the beginning in the way the new pieces of software will be developed. So there are some initiative in terms of research. As Ron said, it's not that common to mix software engineering and aging population, that think that are more into living labs, mobility, Internet of Things, and those kind of things. But there are some things that do exist, like the RUBA workshop with the Requirements Engineering Conference, the AgeWell Network of Excellences that is kind of disappearing right now, or the Answer Creates that do exist by mixing things like design thinking and mobility. That's interesting. And also we need to improve our teaching by finding a way to train students, support collaborations, and exploit and leverage all the possibilities that do exist in this context to support it. So today's presentation will be about, first of all, software engineering from a very broad point of view, like software engineering 101 in 5 minutes. So for sure, we're not going to dig into the details, but more to give you an overview of what can support development for the aging population. Then I will describe a project-based course that we developed together with Anne-Marie, and I will zoom in the one that is developed and implemented on the French side. And then finally, I will show you some example of graduate projects that were done in Anne-Marie's lab, actually, about software design to support the aging population. If you do have any questions, do not hesitate to write them on the chat while I'm talking. I can monitor the chat while talking a little bit, or if you want to just ask your question and take the mic, really do not hesitate to do it. It's more interactive and kind of good. So if we look into software engineering, the point of software engineering is really to support the transition from programmer to software developer. So it gives you tools, method, techniques, good practices, guidelines to become from someone who's able to write code to someone who's able to program to someone who's able to develop. So developing is not only programming, but it's taking into account a lot of different contexts and factors in the way you're developing the software. And then, including and accumulating experience, you can at some point starting to call yourself an architect and be able to develop like things at a bigger scale and have like a broader vision about the definition of the software. So usually when you talk about software engineering in the context of software development, a lot of time people think that it's a scale problem, it's a size problem. If you're trying to develop a small thing in your backyard, you do not need the same techniques than if you're developing a roller coaster, because at some point in the picture on the right, people can die if there's a problem, but in the picture on the left, it's less, there would be less risk in a way. So often, software engineering is related to problems with security, safety, verification, validation, all these kind of things. So it means that when you're developing your application, you can say, okay, I'm not doing something big scale. So I don't need software engineering techniques or method to develop my software. So I would just like to dig into an example of something which is not a roller coaster, something which is quite simple, which is browsing the web. So if we took an example of Firefox, which is one of the main leading browser, but the numbers for Internet Explorer or the numbers for Chrome would be the very same. Firefox was developed by more than close to 8,000 people, and it represents something like 22 million lines of code. Something which is as simple as browsing the web. It's this level of complexity. It involves more than 24 different languages. In terms of developments, and more or less it represents close to 8,000 years of effort combined together to allow you guys to browse the web. So scale is not always where it looks like, and we're not building a web browser doesn't look that big, but in the end it's kind of a big and complex class of software. But well, you might not be building a web browser, you're building an application for doing something in the context of your project, for example, for this answer program. So you can say that, okay, I don't need this, and this is not useful because my app is small, because I don't really need to use all those tools that software engineering researcher and practitioner are pushing, because I will lose my time. That's something you often hear, actually, like, no, I don't need to do testing because, well, I wing it. I just don't need to do tests. I'm programming, so it will work. And also the fact that, okay, I'm not developing a big software, so this piece of software is not that big, so I don't need all your techniques. It will slow me down. That's maybe true, maybe not, I don't know. But what is sure is that it's also totally disconsidering a huge part of software engineering, which is about humans. We talked a lot about size, and for sure, size does matter in the context of software development. But it's also, we need to focus, and we do need not to forget about humans. And in our case, humans can be the developers that are working on the software to be developed, and also the end users that will be using the system, like in our case, the aging population. The first point, and the thing that is the most important here, is when you're developing software, you need to have a shared understanding inside your team. So focusing on developers. If your task, like the software is trying to develop, is to cross a river, it would be a pity that half of the team is trying to build a bridge and the other half of the team is trying to build a tunnel. Because if you do this and you realize it's too late, then in the end, crossing the river would be taking the bridge and then take an elevator that go through the river, reach the tunnel, and then go to the other side. So it's like not the right way of answering the question. So software engineering helps you to define a way to write your specification and be sure that you're sharing a common understanding of what are the tasks to be done and how they're going to be performed in the context of the project, to be sure that everyone is like working and moving into the right direction. To do this, basically, we are relying on agility for a lot of things. Agility, it's a way to develop software in an iterative and incremental way. So the idea of being incremental is that we're not going to build a final product at once. We're going to build several iterations of the products that will be incremented each time. It's related to, if you think in terms of design thinking, it's related to the kind of making prototype, demonstrate, and then improve the prototype and demonstrate way of designing the product. And it's also on a very more cost reduction point of view, a way to reduce your risk. Because if you wait for the very last minute to deliver the software, then there's a huge risk, which is defined at the red part here. Like, yep, it's not working. This is our risk. That the product doesn't fit the end user expectations because, well, basically your cost is always running. You need to be paid to develop the software. So the cost is a linear function, and then you're not delivering anything. So there are huge risks that what you deliver will not fit. If you're using an incremental and iterative way, incremental being delivering regularly your software, well, you're like basically reducing the risk because there's less risk that what you're delivering is not fitting what the end user wants. So using those kind of approach helps you to reduce cost and be sure that what you're developing is aligned with what the end user is expecting. So that's where you can see that there's kind of a continuum between the way the software is developed, so the responsibility of the development team, and the way the end user will perceive the product, because it gives you if you're able to regularly deploy it and regularly make your product available to end user, then that's a way to reduce risk. But then one important thing here is the green curve, like what is the value? How can you define the value? And to do this, well, the point is really to be able to identify in all the tasks, all the things that need to be done in the context of a project. If you try to do everything, then by design, you're dead. Because the idea of software with like opposed to hardware is that soft is by design soft, so can be changed over time. So new tasks, new things, new feature will always accumulate. So you need a way, in an engineering point of view, to find a way to filter all those tasks, all those new features, to not try to do everything, like not load all the bricks inside the truck, but only load to the truck the bricks that are the golden one. If you do this, then you can be lazy because it's less work to do, which is kind of a good way of life, actually. Work less for better value. And also, it's a way to be sure that what you're delivering is the things that are expected by end user plus all the stakeholders. So we're really, in this context, trying to define the like the value, the minimal values that we can deliver with the maximal value we can deliver with a minimal effort, to be sure that the project is only composed of golden bricks. And to do this, we're going to include in the way we are specifying the software things that come from the design point of view and the design community, which will be personas. So we're trying to characterize here who are the end user and what are their demographics, where they came from, what are they doing with the software, why are they end user of the software, and how can they interact with the system. And by using this, it gives you a frame to be sure that what you're developing is really aligned and done in the right way. We're trying to do the right product for the right person in the right way. And if you miss the right person, if you miss the right end user, then you can do the best product, but it's not what the user is going to use. The user asked for a washing machine and you've built a Ferrari. That's really nice to drive, but that's not washing my clothes. So it's not what I need to do. To do this and to support this kind of development, well, you basically need to evaluate what you're doing because, well, we're scientists, so we need to find an evaluation basis. This can be done at very different stages of the development. when you're the developer, you can have a short-term and immediate feedback by focusing on testing. Like writing unit tests, it's a way classical in software engineering to have something which is a red-green flag on the code you're developing. You're writing your code, you're running the test, immediately it gives you a red flag or a green flag if it's working according to the test or if it's not working according to the test. So that's really a short-term feedback loop that you can obtain as a developer. This is purely quantitative, like it works, it's green or it's red. You can count the number of green, you can count the number of red, but it's not really much more than this. And it's also imperfect because there are some situations that are not going to be tested. So you can have like holes in your racket. At the totally opposite part of the spectrum, you have things like end user evaluation, which is a kind of collaborative workshop you can organize according to design thinking method. It's more long-term because you need a product, you need a prototype, you need something to demonstrate actually, but then you can include your end user, you can include your stakeholders, and you can observe how they're using the product, you can discuss with them, you can interview them, and then you can collect qualitative feedback. That it's another way of collecting information and improving your product to be sure to know what is going to happen in the next iteration, in the next increment of your product, what are you going to include. Main issue here is that you can clearly see that the code on the left, sorry, and the kind of workshop that you can organize to support the evaluation on the right, there's kind of a huge gap between those two because it's like really different, not used at the same time, not requiring the same maturity for the product. So in this context, in software engineering, what we're trying to do is to identify acceptance scenario and a way to specify the product that bridges the gap between those two. To do this, we're basically including the personas in what we call user stories, which is a way to develop the software as a set of like specification written as stories. So a story, it's a tuple, including a persona, one of the persona you define, an action that this persona will do with the system, and the benefit that this persona will retrieve from the system by performing the action. It's often written in as someone, I want to do something so that I retrieve a benefit way. So that's named the connector template. And you can say, like in the context of something you're designing to create orders in a bar, you can say that as Romeo, which would be a waiter in this case, I want to create an empty order so that I can add drinks later in my order. So that's the kind of way you can use to specify. And which is interesting is that this specification here, it's kind of still, it's kind of far from the kind of unit tests that you can have at the code level. So one of the main contributions here is to define what we call acceptance testing, acceptance scenario, that are this way of representing how the user would accept that this feature is done. And in this case, it's really written like a scenario. Given someone who wants to create an order, then if we declare that this order goes to Juliet's table, the order does not contain any drink. And if these scenarios go through, then it means that the feature is done, and that's good for my system. And which is interesting here, as software engineers, we're trying to automate as much as possible. We have ways to automatically translate this into unit tests, like to transform this kind of literal programming that can be done by a product owner, can be done by a quality analyst, can be actually shown to the customer. You can share your acceptance scenario with someone that can read this, can't read the unit test I was showing you before, but you can read this and understand what's happening. And then as this is translated automatically to unit testing code, it can give you the kind of immediate feedback that you can obtain, but at a higher level of abstraction. And that's also something that we try to do in the software engineering community, finding the right abstraction to make sure that everybody is sharing the same understanding of what's happening. I can't show unit test code to my nurses, I can't show unit test code to my stakeholders, but I can show to them fears and acceptance scenario. That's kind of the right way to do it. So let's use this level of abstraction to be sure that we reach this shared understanding. And finally, the last part of software engineering I wanted to discuss today was the point about DevOps in a way. We talked about end user, we talked about developers, but we also need to talk about the people who are on the IT ops side, the one that are deploying and operating the system. You're creating a mobile application that will be deployed on people's cell phones. Okay, perfect. But maybe it requires a server. Maybe it requires to be sure that there is no scalability issue, like you don't have too many users that prevents your application to like be outlined or do not have the good service level agreements. To do this, what we're trying to do right now in the software community is to push things like the DevOps paradigm, which is about creating this kind of infinite loop between developers of application and operations, like system administrator who are operating the software. And by bridging the gap between those two, there's a way to start by building the code, of course, and then it goes through testing, it goes through releasing, it goes to deployment, and this needs to be done in an automated way. So each time you're writing your code and say, okay, my tests are okay, so I can push this feature into production, then this like line goes into deployment automatically. And then the people who are operating the system can run the operation, monitor the server, gather feedback, but technical feedback, where the qualitative demonstration or a workshop you can operate with stakeholders is more about qualitative feedback about how the end user are perceiving your software. Here we're talking about monitoring how it's running at the technical level. And then those information can go through the next planning. So would you interact in your, would you integrate, sorry, in your next iteration, the next version of the product will include new features, but can also include things that comes from the technical point. So that's the kind of things we want to do with those kind of like development loop. This was a very like bird high coarse grained view of software engineering, and it was really from the point of view of including user. It's not about human-centered design, which is something a little bit different, but it's really like in software engineering, this is a state of practice, and this is what we can do to include users as much as possible into the development. And then what we're trying to do is then find a way to teach this and find a way to make it really clear for students that this is the kind of things you can do to the development of software. So as Ron said in the introduction, there's a huge history of including, being inclusive in the way software developments and software projects are done in the at Université Côte d'Azur. Anne-Marie and Jean-Paul and Hélène started working on this in 2003. So it's kind of 18 years ago. And the first version of this project was about designing serious games for visually impaired children. It was always including collaborating with a caregiver and people like nurses, real users. We had this workshop where all the children from the school came to the Faculty of Engineering and were trying the demonstration of the student and the prototype and those kind of things. Eventually, what we were doing was an evolution of this into working with the aging population, and Anne-Marie has a very strong history of working with people suffering from Alzheimer's disease, for example. It brings actually kind of interesting challenges, because if you try to teach requirements engineering and software engineering in this context, it's kind of different. The main difference is the potential and availability of end user. If you're teaching requirements engineering, you will say to the students, okay, go talk with your customer, talk with the end users. That like the main important thing is to talk with customers. But if you talk with someone suffering from Alzheimer's disease, for example, you will not obtain the answer you'd expect to be able to take the right decision. So you need to use a proxy. You need to use someone who is able to answer on behalf of your real end user, which changes a lot. And it's really important to include this in the teaching and to train and sensibilize people about this, because all the classical method requires you to discuss directly. And it's really like necessary to be sure that you're gathering the requirements, taking into account this kind of proxy indirection level between you and the real end user. And there are other things that we are working on and which can be problematic when teaching and training students about this is that aging comes with like small impairments at the beginning. It can be visual impairment. There's more people suffering from age-related macular degeneration in the US than actually it's close to the number of inhabitants of Quebec, which, okay, Quebec is not that big, but still that's a lot of people. You also have motor impairment if you're designing a mobile application and you're not taking into account that your fine-grained mobility will have issues at some point based on the fact that you're aging. It can be a problem. And you also have some cognitive impairment, like suffering from memory losses, or in case of really degenerative disease, it can change your behavior and the way you react in front of the software. And something interesting here is that there's a lot of people working on visual impairment. We know how to make software for blind people, for example. There's a lot of things related to motor impairments. We know how to make software for people who can't use their hand, or people who are paralyzed, or those kind of things. We know how to make things for people with cognitive impairment. It's also a problem. But aging is not about being impaired. Aging is not an impairment by itself. It's a composition of small things on those three different levels that makes it very difficult, because you need to be taking into account a lot of different things in the very same product. And that's why you start to have problems. And that's why you need to have this shared and common understanding of what you're doing. The methodology we're using is a problem-based approach. So we're basically asking the student to develop something, and they have to use personas to identify what they're trying to develop and who are the elders that will use the system. And they're using stories to describe the features. And then for the validation point of view, we're having something which is dual. First, we have facilitation provided by the teaching team, because I mean, it's been 18 years that they're doing this, so they can be like provide immediate feedback to students. Plus, we're organizing demonstration, can be twice or 3 times a year during the semester, to include stakeholders. And so stakeholders, the end user, are not part of the development team, which is kind of a difference with classical design thinking, for example, but they're kind of used as validation steps in the context of the development of the project. And this was developed in a common way. So we've designed a set of courses, which are unfortunately in French, but it's a French-speaking Alliance funded project, to define a common core about how to do requirements engineering for the aging population, taking into account those kind of specificities. And we also leverage the local specificities of the different partners. So Anne-Marie, she's working on human-computer interaction, and she had this collaboration with Alzheimer Center. So her part of the course was more related to this. In the Institute of Technology, it's more about project management and how you organize your project in terms of taking into account those people and supporting those demonstrations. And finally, at UQAM, there's more stronger part on artificial intelligence and using sensors, because I'm kind of working with that issue a little bit, and how to use them to like classify behavior of the user. And of course, all those things were kind of slapped in the face by the COVID crisis, and we had to redesign a lot of things. So it requires way much more preparation than we expected. But in the end, it was lighter for the students because everything was like super prepared, and they just had to like kind of follow the lead. Quickly, the case study that was used last year was about defining a quiz game. So defining a quiz is basically who wants to be a billionaire, but as a school project. So you can say, okay, that's a really simple project. I can do it in 2 days. So that will be quite simple. And that's what we want to obtain as a reaction from the students, because then they realize that it's not that simple and it will be really complicated, and it requires efforts, even for something as simple as a who wants to be a billionaire version of a quiz, to take elders into account. Using personas was really helpful because it helped a lot the students to be inside the elder shoes and try to be sure that, okay, if I would be this person, would I do that? And they were able to answer this quite easily. And we also organize those demonstrations that were done remotely because of the COVID, so not really helping, but still we obtain kind of good results based on this. I will just show you an example of the things we can focus on in just as simple as using a quiz game. If you're suffering from age-related macular degeneration, then you will be you will lose the center of your vision and not your sight. If you're suffering from a glaucoma, then it's basically the exact opposite. You will lose the sight of the vision. So this helps us to teach and make the student really understand things like the door principle in the HCI community. You should not design your requirements for the average population. You should focus on the extremes. If you're designing a door to enter a building, if the door height is made of the average population, then half of the population can't enter your building without bending the head. So that's a problem. And this is kind of very typical when the students can see this and immediately they understand that, okay, I can't work on the average case. It's not averaging everything, it's really taking into account the kind of specificities that are required by this. Another good example for this is the cognitive adaptation. You're designing still a quiz game, and if you're in front of someone who is, for example, suffering from Alzheimer, being in front of a failure can trigger anger crisis. So you don't want to trigger those kind of things. So one of the good ways to tackle this challenge is to change the game mechanics, to not say that you've made a mistake, but to just postpone the question and re-ask the question in one or two questions by removing the wrong answer. So eventually you will lead to the right answer, and then it helps to not trigger anger crisis. But still doing this, you need to think about a dual point of view, because then you need to think about the caregiver that would observe the situation and observe the evolution. Are you answering more and more bad answers to those questions? Are you answering bad answers to personal memory or to global knowledge? All those kind of things can help to support medical staff or people that can observe how you're being autonomous at your place, for example. And this is something that you need to take into account intrinsically. It's part of the development to take care of this duality. What was fun as a lesson learned on this course is that the course is not elective, it's a mandatory course. So all the students, 120 students, has to follow it each year. And they're basically saying that it's an exciting project working on a social challenge. So they're kind of being aware of that being inclusive in terms of elder and aging population is important. But the main lesson they're taking is that if you're confronted to a situation you don't know about, you have no idea. And it's not that you have no idea, it's that you have the wrong idea. You're going to take very bad decisions. So you need to understand the situation. And that's why you need to include people with disabilities, elders, people from different communities, to be inclusive in the way of validating software. So it's for sure very explicit when you design software for the aging population, but it's more global. It's being inclusive is not, it's something way more global than what you can expect. One of the main drawbacks is that not the majority, but some of them said that interacting with elders and caregiver, especially when the elders are suffering from disease like Alzheimer, that can be making you uncomfortable in a way if you're not used to this. It requires energy and it requires being in the right state of mind to support the demonstration and be sure that everything is going well. So to conclude this part, the professor's perspective on this is that by collaborating, and that's a kind of philosophy that also exists in the Answer Create program, it's collaboration of professors to support the definition of those training programs, it clearly leads to improvements. And actually in our case, it helped us to make some decisions. For example, we used at UQAM, we gave to the students a tool that was simulating visual impairment, sorry. And in NIS, they were just using it for grading. So it helped us to have discussion about what are the pros and cons about those kind of different system. And also it also happened that the tech choices we're making can be different. Like at UQAM, I'm more working on a mobile application. In Nice, I'm more working on a web application. So it's easier for me to use sensors, and it's more complicated for web application to investigate the fine-grained mobility issues that can happen. So that was interesting. To conclude the presentation, it's about, I will just show you quickly 3 projects that were designed in Anne-Marie's lab. So Anne-Marie has a very nice lab in Nice with a lot of gadgets and a lot of things. And one of those things is an interactive table that can be used to recognize physical objects. So with her students, they developed a way to help people to exercise their routine and day-to-day memories. So you have things like a glass, a toothbrush, and toothpaste, and you can make kind of a serious game to help people say, okay, in which room of your house the toothbrush should be, where the toothpaste should be, where the glass should be, and those kind of things. And then you just put it on the table and it recognizes the object, and it helps you to like support the people that are interacting with the table. Another example using the table is the scheduling tool that you are asking someone, okay, you need to brush your teeth. So in which order are you using the toothpaste, the toothbrush, the glass? Do you need to put the toothpaste on top of the toothbrush before using the glass to rinse your mouth and those kind of things? So it's always by interaction with physical objects that you can use the table to be sure that everything's going fine with the elder using the system. Last project that was I mean, she has dozens of those projects, but those are the 3 most interesting for this presentation. It's a smart mirror, so it's not a table, but the mirror will look at how you are interacting, and in this case, how you are brushing your hair. And it can help you to say that, no, you have to first take the brush and then brush your hair and those kind of things. It can give you advice and can show you demonstration or gives you hints about how to do it. And that's a way to represent and support people in all of those 3 applications. The point here is to give times to the nurses to take care of people who really need help, and help people, and that technology can help people who are just not requiring this level of help. So having something which is lighter, and then technology can
a few questions where other people are probably still trying to phrase their questions. So in your undergrad course, you mentioned there had been some difficulty like interact.
and
And those interactions, are those entirely in person or is a mix of in person and like some video conferencing?
In a non-COVID world, it's in presence, because actually the collaboration in Nice and in UQAM are done with centers that are quite close to the like physically close to the place, so it's not that complicated to move people from one place to the other. Moving virtually could be complicated because it requires kind of a logistic that could be difficult, and it's easy to start a video conference with a nurse or with a physician or a psychiatrist without any issues. But with elders suffering from dementia, then it's totally different game, and it's way more complicated. So we kind of, the COVID implementation was like more disconnected from the end user because of this, and also because the like wasn't a good time to go to a retirement center during the pandemic. So there, that's, yeah, basically this. So in presence as much as possible, because that's where you can, and also for the demonstration, it's way better when you observe people using the software. You can like be silently observing what's happening, and if you're doing it in a remote context, then the evaluation methodology and a protocol would be completely different, and you can't really observe what's happening. So it's kind of more invasive. So it's introducing bias in the kind of things you can collect. So this can also be a problem.
Yeah, absolutely. I think in person will be very valuable. It's just we need to adapt with the limitation imposed by the pandemic. Another question is, I'm kind of curious. You also mentioned briefly that still for like most of undergrad software engineering curriculum, they're more focusing on the fundamentals and the key methodology. So what is the rationale to incorporate this component at an undergrad level?
That's a political question, actually.
Yeah.
At the in Nice, it's kind of part of the DNA of the school. The first project related to visually impaired children started when the school hosted visually impaired students. Like Karine, she was blind, and it requires a lot of adaptation in the school, like physical adaptation, because the school was full of traps for blind people that were like really dangerous, like falling in the stairs and those kind of things. So it's sort of sensibilizing people about this, and then creating a course about this and introducing it in the curriculum looks like natural, actually. At UQAM, let's say I had to fight a little bit, and the rationale about this was to basically leverage the EDI concerns about this, and that EDI is not just about being equal, diverse, and inclusive in terms of recruiting students or kind of things, but also in a way that teaching students to be inclusive was kind of critical. So when I found this lever, then it was like, oh, okay, let's do it. But before it was more, no, it's just like creating a mobile app, like anyone can do it, and it's not really important, and you should focus on, you know, artificial intelligence, because this is where the future is. And having this kind of finding that, okay, but you need to be inclusive, and that's the very point of the course, and that's what we're going to do. And we're going to, of course, focus on elders, but still kind of like plant the seed of how to design inclusive software. Then that was the starting point.
Right, but the requirement engineering is still the core of it, although it is tailored for
Yeah,
software development for older population.
totally.
Okay, that's quite significant effort. There are other questions?
Hi, I have a question. I really enjoyed your talk. When it comes to like accessibility on the web, I find it's pretty difficult. Like there's a lot to wrap your head around, and that's mostly what your talk is getting at. So are there any like resources that you found that are really helpful in terms of getting a grasp on accessibility as a whole?
The accessibility is a really large topic because it covers a lot of different things. Like it can be things as obvious as last name. A colleague of mine who's named Claire Le Guez, she has a blank space in her last name, and then she can't provide recommendation for the National Science Foundation in the US because the system is telling her that her name is invalid. And knows that's actually her name. It's just like the system, which is not inclusive, or you have this kind of things that could be quite easy. And if you realize that even for just typing in a last name, there is some accessibility issues, then for things like including elders to support like tax return declaration in France, then it's a way different game and a totally different level of issues, challenge, and problems that can happen. There's an effort in terms of standardization from the web, which is the YE initiative from the W3C. So it's Web Accessibility Initiative that defines standards to describe what an accessible website should be. But kind of like wrong question. It's a political question, because if the browser, the web browser does not require a website to be accessible and still accept websites that are not applying accessibility best practices, then there's no reason to do it, because, well, 95% of the population can browse the website. So why should I spend money to develop something really complicated for those 5%? I'm still making money, so I don't care. And until those web accessibility initiative guidelines are not enforced, like strictly enforced, like I'm not displaying your website if it doesn't go through the YE validator, then it will be really complicated to push this to the web, because the web is open and decentralized by nature. So anyone can publish anything on the web, anyone can publish it in any way. So there's no way to support it. Not sure if it answers your question, but that if you really want to dig in this, the Web Accessibility Initiative could be like a really good starting point to look at it.
I'll take a look into the Web Accessibility Initiative. Thank you.
Thanks. Any other question? Usually when we're in the same room, I usually throw something to someone to ask a question, but I can't do this on Zoom.
I actually have a more on the technical side, this more directing towards Anne Maria. The project, I assume that the table is targeting people with dementia, right?
Yep.
So, so for people with dementia, they tend to get confused. So if there are a lot of visual objects, would that create problem? Like, what are the design consideration that has been implemented to address that kind of challenge?
One of the main interests of using the interactive table is its capacity to recognize physical objects, because you can put some like smart tags on the objects that will be recognized by the table. So in the end, you can have the table like a regular coffee table. It's kind of the size of it's like 1 meter or something in width, and you can like just put the tags on the objects that are used by the people. Like regularly, the glass they're using in the morning, their toothpaste, their toothbrush. And so they're basically working with their very own objects. So that's a way to make sure, and it's just like gluing a tag, and then you can remove it and using it for another person. So by doing this, you're kind of like reducing the gap. They don't have to learn like another toothbrush, another toothpaste, another glass. It's the mug they're using in the morning. It's their keys, their very own key tag that can be used, and that's a way to make this possible in a way. And the software in the table is the very same, because it's just you just put the tag that this is the keys, this is the toothbrush, this is the glass, and then it's recognized by the table.
I see. So you actually use a real object to trigger the kind of information that needs to be displayed.
Yeah, totally.
Okay.
It's like on the table, you have a toothbrush, a toothpaste, and a glass, and those are the really things that you need to use to interact with the table. It's not tactile, so you're not like touching the screen. You're really like putting the stuff in the table, and the table reacts to which object and where you put it. Okay.
Another question in the context of requirement engineering, you mentioned earlier, aging is not one thing or one impairment, but also it's something that's developing gradually over time. So in terms of requirement engineering, so when you think about this population which have conditions that evolve over time, what approach do you take to potentially adapt the design? Do you like set up the boundaries and say, okay, we are targeting, take dementia as example, or maybe just early stage, or there are ways to sort of evolve the software requirement and design the software accordingly that have this kind of ability?
That's what your question is related to like compositionality of the software you're designing, because you need to define your software in a way that can be modularized like a little bit to, for example, be able to activate an adaptation for someone who is suffering from IRMD, or activating another adaptation for someone who is suffering from glaucoma, and which is important. So those kind of adaptations are triggered by a caregiver, can be triggered by someone who said, okay, I have issues to see the information, so I will say something like this to the configuration, and then it will produce the right way of displaying information. But also it triggers things that there are some adaptations that can't be used at the very same time. It's triggering interactions in a way, because if you try to activate the IRMD and the glaucoma at the very same time, well, you'll have a blank screen because you don't know where to put the answers in this case. So finding a way to organize the different adaptation and finding a way to compose the adaptations together, that's like an open research question. So it's it could be really complicated. And what we try to do at the training level, so undergrad course related to this, or even in the graduate courses, is to be sure that the students know that they don't know, that they can't say that this is an easy problem to answer. Well, actually not. Just look at this very simple example. IRMD, glaucoma, you can't do both at the same time. So you need to design your software in a way that it will be able to say that those things are interacting together and can't be used at the very same time. And you need to be able to activate one, the first one, the second one, but not both at the same time. And if we manage to do this, then the students know that, okay, in another context, I still have this idea of features can interact together, and that one adaptation is good for someone and can't be good for someone else. So there's the need for configuration and finding the way to express the right configuration for the right person.
I see. That's very interesting.
Sebastien, so going back to this explanation, what if you put both on the screen at the same time? Would it then that way whichever like both people with both problems will be able to see in the right place? Do you know what I mean? Like, am I probably not explaining myself properly? But if you if you kind of assume that there could be a person with this problem or with this problem, glaucoma or macular degeneration, but it's hard to determine or hard to tell which person is going to be using it, why not put both at the same time? Would that be too confusing to people maybe?
That's one, the main problem would be confusion, but that's also something interesting, that when you compose those kind of adaptation, then the answer is not always the most obvious answer, and you can try out of the box things like what you're saying. Actually, if you put both, then of course, if I just can't see the middle, or if I can just see the side, then I can do both. But the problem is that it's not the so this kind of things can work. It's called in software engineering we call it a 150% model, where you're superposing things from different point of view at the very same place. So you're providing way too much information, but as each people just see a point of view, then it works because it's like separated. In this case, it doesn't work because the boundary between macular degeneration and glaucoma is not that clear. So it would be that you can see something, but also a little bit of something else, and then it can be disturbing, and then it can catch your eye, and then you're moving your sight, and then it means that the point of view changes, so you're seeing even more, and it can get really confusing in this case. But the idea of superposition of information, it's actually a good idea, just like it doesn't work in this very case.
All right, so if there's no further question, we actually was a little bit over time. So let's thank the speaker again.
Thanks for the invitation.
Yeah, hope we can get in touch later on on the potential collaboration on this. It's definitely very interesting.
Sure. So, well, have all of you a nice day, and thanks for the invitation. That was I was really happy to be invited.
Thank you. Thank you so much. That was so interesting. I'm not, I'm just in administration, but I honestly could follow the information very easily, and it was so interesting. So great research and great presentation. Thank you.
Thank you very much.
All right. Thanks everyone for attending.